Welcome to Inside Builder channel, large language model automators, Python experts, and my dear friends. Instruction tuning AI model for custom performance. A guide to instruction tuning your own artificial intelligence model. We will be using TXT AI, a module called TxtInstruct from TXT AI for this particular discussion. The challenge that is getting solved in this discussion is to customize your model. We have lots of open source model, and these models might work with general data that is already which it has been trained upon. But if you want these models to work upon any specific data which is related to your business, your context, then these models will have a tough time. You might think that we can use the vector stores and give our context as the vectors and the series of documents. However, there is a limitation for that because the open source models that we as an individual will be able to operate is in sub 10 billion. Above that 10 billion, you will require a GPU, you will require a good infrastructure for making it to run in your premises, or that is on-prem. Even if you're going to make it available using the APIs, you still have to manage all those stuff, right? Not a regular model is not going to cut it. How to actually make these regular models to do better? That is the main challenge. And to make these regular models, the regular open source models to do better with specific instructions is to give or train that is called it's called as tuning, instruction tuning with new instructions and corresponding reply. So in order to tune these models with new instructions and corresponding reply, you guessed it, you need datasets. And for creating those datasets is where TxtInstruct comes into picture. Once the dataset is created, all you need next is power, infrastructure investment, and time to train it. But the number of parameters that is going to be in the model is going to be much lesser than what you actually need. So what happens here is a kind of a knowledge distillation happens so that you can achieve what you want to achieve with less number of parameters in your model as well as lesser size of the model. This gives a lot of benefits like the speed of the reply, the amount of RAM that you require, or the whether you need a GPU. So all these things are the huge benefit that you get from using this kind of instruction tuning. Yeah, there is time involved, there is infrastructure involved, you will require power, but not to a level where you will have to train in hundreds of billions of parameters. That is a different way of doing. So that is blanket way of getting the tasks solved. But for you as an individual or as an organization or a team who is concentrating on a particular product will have a very specific need or a very specific context in which the model might has to work, or very limited number of tasks the model might have to do. When that is the case, why to invest on huge models? It doesn't make sense. It's inefficient, right? And when you're going to allocate capital, that is money, to those models, the money is not going to be used properly either. So all these things we need to think through when we decide on coming to the customized model. So I hope that with this current introduction, you understood how the customized models are going to help you as a business developer, as a leader, and how you can actually leverage this new information to build large language models, and which are actually small. So that is the key point that I wanted to share with you guys. So if you guys are new to this particular discussion, I would really suggest that take a look at this particular playlist where I talk about mastering NLP with Hugging Face, where a lot of discussion on the tasks these models can do, the type of models that is available as open source. All of these points are discussed in this particular playlist, so you will get an idea. Also, I have discussed a lot about the TXT AI's pipelines, the TXT AI introduction, etc. Also, so do take a look at this particular playlist. I will be attaching this playlist also in the end of this video, so you can take a look at that too. With that said, let me go back to the PDF and continue with the discussion. So what are the steps that is required for instruction tuning? It's very simple, similar. as I explained in the challenge, so you will first need to decide a base model that you want to work upon. So you might, as an organization, you might already have a base model, or you might be ready to use any of the open source model that is, commercially acceptable to use. And then you have to create the data set. For creating the dataset, you need to have a context and you need to decide the instruction that you are going to ask the model to complete. So these three things you have to decide. So it's like you are going to build a Python function. So when you are going to build a Python function, what will you do? You have to first decide what the function will return, right? That is where the entire design starts. The architect will think, okay, I want to get a return of such and such variable, and the Python function will be a black box. Same way, the model that you're going to develop will take a particular instruction with a context, and the output will be a particular completed service, so, or a completed task. You need to decide these three things: the instruction, the completed output or the task, and the context that will be used. These three things, once it is decided, then you need to create the base data set. The base data set will be the context that you are having. It will be a series of text, sentences. The context might be the explanation that you are providing about a particular service, or it could be a content of the content that describes the product that you are having. It could be a copy, it could be a advertisement, it could be any number of things that you can think about. But yeah, these are the examples that I'm providing you. Once that is done, then you use that context and then you create instructions and corresponding replies. This is the step which is going to be difficult for most of us. I mean, in fact, see, a lot of people can actually create instructions, but creating the output that that instruction might solve could be a challenge also. So we don't need to worry about it. There's a way to solve this problem, and that problem is what is solved by TxtInstruct. Got it? So this is the specific problem. The problem of generating the instructions and the reply pair is what is solved by TxtInstruct, and we will be looking at in detail in the next slide. Let me proceed further. So once the data set is ready, then you are going to tune the model. Okay, so as we already discussed about the challenges that we will face. Now, what actually TxtInstruct does and how it does by creating the data set. So it starts by TxtInstruct has three different parts internally. So first and foremost, there is a statement generator. Second, there is knowledge source, that is for the context. And third, there is an LLM, which the large language model, that the base large language model that translate the source to target statement. So keep this in mind continuously, right? The first two steps, the statement generator and the knowledge source context, these two together will create the data set. And the next step, where the data, after the data set is created, you will send the data set to a next, this is called as instructor basically. You will send it to the instructor, and the instructor will create the new model. This, when I am explaining it theoretically, it's extremely confusing. Okay. And when I was reading the instructions when I was reading the descriptions provided in TxtInstruct's GitHub repo, README also, I had, I was a little confused too. But my confusion evaporated the moment I went to the code. Okay, because in the code you can see the data moving from one object to the another object, and you can see how the data is getting transformed. So you will understand what is going on. So don't worry if you don't get what I'm trying to say in this particular slide. The step which we are going to use is statement generator plus knowledge source. These two together will create the data set, and the data set will be given to the instructor, and the instructor will create the new model which will be used in the extractor. Okay, all these parts, the statement generator, knowledge source, dataset builder, instructor, extractor, all are part of TXTAI. So if you are new to TXTAI and TxtInstruct, I would really suggest that take a look at their documentation. It's pretty simple. It's a Python library that is specifically made for one purpose. So you will actually learn it in if you're even a medium level experienced Python enthusiast like me, you will be able to catch it in less than 4 hours. So yeah, give that 4 hours though. That is more important. Now, I have actually got this particular example that is inside the TxtInstruct's README. I have taken that and I have written. I just copy pasted that example as my notebook. So this particular notebook, I actually break the example. So what I do is, if the example that I get in get from the Python libraries examples, I take that, but I break into multiple smaller steps, and then I create the GitHub. Then I create the Jupyter notebook. In this way, what happens? I understand first of all what is going on, and I actually share that particular notebook with you guys so that you can practice it and learn easily. So that is the point that I have shared here. And there are lots of things that you are going to learn in next couple of minutes. So buckle up, and yeah, these are a couple of information that you will get from this particular notebook. So let us head to the browser. The notebook is already hosted in the repo that you guys must be already aware. If you're following my YouTube channel, do subscribe to my channel. The point I always make whenever I come to this red slide is that you guys have to practice. The intention is that when I started, trying to understand TxtInstruct, it was not easy, because it's not something which is very intuitive, right? First of all, I did not understand what is the problem that it is solving. But after digging in, trying to work with the primitives, work with the data that is already available, and moreover, the data is really big, and you cannot just like that pull it to your local environment, because there is going to be bandwidth involved. You have to work with the models, GBs of data. At that time, you have to manage those stuff, the bandwidth, the resources, etc. So do practice around these things also. The more you practice, the confident you will become in managing tougher situations. With that said, I hope you like this content. Do leave a like, share it with others, subscribe to my channel for further discussion, not just on large language models. I discuss about Python ecosystem as a whole, with respect to artificial intelligence, with respect to big data, with respect to vector stores, and whole other problem solving options that is available in Python. With that said, let us go to the browser and the code. This particular code, you will see the same thing that I've explained in the presentation. I am also explaining it here. This is the GitHub repo where I am starting this, where I am hosting this particular Jupyter notebook. And if you're wondering, okay, what is Lamini exploration? So it started with the TxtInstruct discussion. Idea to use TxtInstruct came after the introduction of Lamini. So you must have already come across. If you have not come across Lamini models, then do a Google search. You will get more information about it. But TxtInstruct is something that I am going to discuss about. With that said, let us go to the Jupyter notebook. So this is a collab environment where I am running the Jupyter notebook, and you don't need to worry about these things. I am anyway downloading these documents from Hugging Face GitHub repo to see how the documents are, how the documents looks. So let me start. So basically, you have to just install TxtInstruct. This is a library on its own, but it's part of TXT-AI. And once you do that, I discussed about the statement generation, knowledge source, and large language model part. So there are three parts. First and foremost, the statement generator. The statement generator is a regular it could be any of the regular text-to-text or text generator model. So that is more important. It should be text-to-text model. It cannot be sentence similarity. It cannot be classification model. It has to be sequence to sequence. That is text-to-text. Once you choose that model, what we are going to do is we are going to tune this model in such a way that it can generate questions from the context. Again, so let me again repeat it. This particular step, the statement generator, what this particular primitive does is it takes a existing open source model. It also takes a open source data set. Okay, the data set should be in the form of question and answers. So let me share that also to you guys. Just give me a moment. If you visit the Hugging Face hub, I hope that you guys have already got a account in Hugging Face hub. If not, do get a Hugging Face hub account so that you will have a better understanding of a lot of model that is hosted there. What we are going to talk about is Squad dataset. The Squad dataset is Stanford dataset, and the dataset has got this questions and the answers. So if you click at it, you'll see the context, the question and the answer. This particular data set is taken, and it is used to tune the FLAN T5 small language model. What happens is, once I tune this FLAN T5 model with this quad dataset, so you don't need to worry about it, just use these parameters. Actually, when the TxtInstruct example asks us to use 0.1, but I have used it as 0.01 here because the time that is required for 0.1 itself is very large. So because the RAM that I'm using, the mission that I'm having is a 12 GB mission, and it's a 2 CPU instance that is available in the collab environment. I am not using any paid service. It's a free service. Everybody, even you, can also use it. That's why I wanted to have a bit of a speed in which we can create the statement generator. So with this parameters, you can actually get a good statement generator, at least for this example. So you might have to play a little bit. Once you do that, this FLAN T5 model, so just go with the flow. Once you complete this, it will take at least 20 minutes to complete this particular step. This particular step will take 20 minutes. I've already done that. Once you do that, you have to send the model and the tokenizer. So you see this part. So this is the output that you'll get after you create the generator and complete the training. This model and tokenizer is sent into the sequence, and you see the statement call that I'm making here. So I'm actually giving a prompt, generate a question using the context below, and I'm giving the context. So I'm saying Hugging Face is an open source platform for all kind of AI models, and you see what is the reply? What is Hugging Face? Obviously, so here the context actually gives an answer, and the model generates a question. So this is what I was talking about. So it generates statements. In fact, if I say, okay, describe, let me change it. Okay, this is going to create a problem. So let me show you what problem it will create. Okay, generate a description. Because see, the point is that you guys have to break the models, break the examples, not the models actually. Yeah, break the examples. Once you break it, you will understand why some models work and how the models work. Okay, so I'm saying generate a description using the context below, and I'm going to just give the, I'm going to execute this particular cell, and let us see what happens. Because I'm not asking the model to, you see this, I'm not asking the model to create a question now. I'm asking the model to create a description, and you see it is actually replying what exactly the description is. And let us say generate let me think for a moment. Generate a news headline. Okay, because these are all these are all tasks or instructions that we can give to the model, and we can see how the model is responding to these things. You saw the difference, right? So Hugging Face is an open source platform for hosting all kinds of AI language models. So you see, once I change the prompt, the output is completely different. Once I say generate a question, and you see it generates a question, because that is the primary task this particular model is tuned for. Got it? And once I get this model, so this is the first model I'm getting. So this is the first model and tokenizer I'm getting. And then what I'm going to do is I'm going to use that model and tokenizer. Okay, this model and tokenizer, I'm going to use it in the next step. So before I go to the next step, I need to pull the embeddings. Okay, so I actually don't need to pull this embeddings. So this step is where I got completely confused. Okay, to be honest, I got completely confused because, see, let me go to the presentation for a moment. In the presentation, I say that, in the presentation, I claim that we need to curate the context and create base data set, right? I provide this particular step, but in the example, if you see, I'm not talking about data set, I'm talking about embeddings. How did that even come? And why the embeddings are there? What is happening is, in case of TxtInstruct, there is already a huge data of Wikipedia information that is already available, and that is already stored in the Hugging Face Hub GitHub repo. We are going to use that. Apart from using the Wikipedia data, that particular Wikipedia data set is already embedded into vectors to speed up the process. And thanks to Numal team, we can use that embedding. This is not created by me, it is created by Numal team. And this Numal team has already stored the information as files inside the Hugging Face hub. So when the next couple of steps, I will show you what is the kind of data that is stored inside. Okay, but I want you guys to understand why I am doing this, why the example is going in this route. So we are just follow the process. We are going to use the embedding class, and we are going to create the embedding instance. And this is the template that we are going to use. This is where the actual, the embedding data you can see. In case of TxtAI, you can use, search the embedding. Embedding in case of TxtAI, this particular instance is like a vector store. Okay, that is the right thing I have to say. This is like a vector store, and to this vector store you can give the SQL like select clause as search statement. So this query that we have done here, actually it is wrong. Let me do it. Yeah, now it is right. This particular squiggly lines are coming because I did not properly close the what is it called, the string. So now it will go away. You see the, just a minute, let me execute this and let us see what happens, because at the end of the day, yeah, now you saw the squiggly lines go away because the quotations were missing. Now in case of TxtAI, you can use SQL like data manipulation language inside the search clause. So you can use select ID and text from TxtAI, that is a table, and you can actually give the filtering options, and then you can get the text output. So this is the context that I was talking about. This is the same context that I was talking about, and we get the ID also. And this context is what we are going to send it as a text here. You see this? And you see this template. So we are, there are 5 different templates that we are talking about here. Like as I was, trying to do it here. So instead of, asking questions, so I was talking about, news headlines, I was talking about description, etc. The same way, you can create the data sets with different types of tasks. So these are all tasks. So tell me about is a task, give an explanation is a task, provide a quick summary is a task again. So you can actually create the tasks, and the text is already provided, this particular text. And then what happens is inside the dataset builder. So this is again another one TxtInstruct primitive in which you are going to give so this is a bigger model. So the Flan base model is the Flan T5 open source model, and so sequences is part of TxtInstruct, and we are going to give the statements and we are going to give the templates. So we know the statements that statement is the model that we already created here. Where it is, yeah. So you see the statements, yeah, the statement generator. Just a minute, let me go down here, and you see statements equal to sequences, and we create the model here. And the next thing is we are going to give the templates. We already saw the templates above, and then we are going to use another one model here. This model and the model that you are using in the statements are 2 different models. Understand that very clearly. Okay, and once you create this builder will need a context. So that is where this particular embedding.search is getting used. So instead of using this embedding.search, and instead of using this embedding.search, you can actually create a list of context. You can actually create a list of context with the object text, and you can place it here, and it will still work. The point is, this is the main point I want you guys to understand. Let me go back to the PDF once for a moment. In the discussion when we are having, I spoke about that you can decide your context, right? You can decide your instructions, you can decide the reply, you can decide the instruction, you can decide the context, but the reply that is going to come out will be decided by the large language model. The large language model is going to be the open source model. We are not using ChatGPT. So keep this in mind. We are not paying any API for any APIs calls or any kind of tokens or anything. This is all done through open source. And moreover, most important point I want to reiterate is that all these things are done inside collab environment. I am not even connecting to any of the inference endpoints, even in Hugging Face. So this is one of the prime advantage of working with instruction tuning. you will have control of the development, and your data is inside the environment where you are training it. This is all huge benefits, right? So once you understand, once you use this context, once that is all done, you will actually get the data like this. So you will see the context and you will see the questions. So what is the field of machine learning? So for this particular context, the open source model is asking the question, it is generating the question. I am not generating this, and the output is the target, that is ML, tell me about machine learning, and the target is the explanation about machine learning. So what is the study on attacks on machine learning? So I don't have the data on that. So such kind of question and answers gets generated automatically after this particular dataset builder is executed. After this dataset builder is executed. So once that is done, once you have the dataset in your hand, this particular dataset will be created and placed as data.json. So this particular file, okay, and that particular file can be used as the input for the instructor. So this particular instructor is where is going to use, or it's going to tune another dataset. So this is going to not the dataset, I'm sorry, it is going to tune the FLAN T5 small model. So this is the smallest. Let me actually go to the Hugging Face hub and let me show you the model. That will be easier for you guys to understand. See, the major challenge I was facing is when I was going through all these things. This is all new for us. Okay, most of us may not even know what is FLAN. Most of us may not even know how these large language models are created, right? And when we are given all this input, considerable amount of research is required. You have to learn a lot of things, and there is an uphill learning curve. But once you learn, then it becomes really easy. So give some time. It's not going to take a lot of time for you, because you know the problem that you're going to solve, unlike learning any other topic. So for an example, if you're going to learn about database, if you're going to learn about let us say cloud services, so there are lots of things you have to learn. But here you are going to with a specific idea or coming, you just want to learn about open source Hugging Face models and how these models are created, what are the libraries linked to it. So you will have a series of questions that you'll have, and most of these questions are answered by Hugging Face hub tutorials and the documents. So you can take a look at that and you will get a good idea. And FLAN T5 model, you can see it here. You can go to the files and you can see the size of this model also, and you see the size of the model is very, very small. It's just 308 MB. You see the difference, right? And this so we are going to use PyTorch model, and we will not be using Flax or T5, that is TensorFlow. We'll be using PyTorch only. And then once you are going to use this model and do the instruction tuning, you will be amazed at the result. In fact, I was also amazed, and that is the reason why I'm making this particular presentation. So after you go through this process, you have to train it for 3 epochs. That is the minimum that you need to do. It is going to take a little bit of a time. Here it is showing 40 seconds, but it might actually change for you. Do complete the training, and then you can use this template. So answer the following question, and if there is no answer, you can say you can. This is it's a basic prompt, and then you can initiate an extractor. And so here the example is trying the existing FLAN T5 model. Okay, the existing FLAN T5 that you see here. Go to the model card. If you go to the model card and if you go here, you can actually try this. This is a text-to-text generation, and so you see this, answer the following yes or no question, and if you compute it, it will start giving you the answer. But so once you actually use this particular extractor, if you ask, tell me about Linux, you will see the answer is just Linux. I mean, it's no use. But once you use the same extractor on the new model and tokenizer, that is, you see this model and tokenizer. Don't get confused with this model and tokenizer and the model and tokenizer that we started at the beginning. So don't confuse with this. This is no more. This particular model and tokenizer has been completely replaced by the new one. So this is a mistake that I made. Sorry for the confusion, but I am reiterating. Do not get confused with the first one that we created. Then once you do that, once you create the prompt, and now you ask, okay, tell me about Linux, and you see a beautiful answer coming out. How is this even possible? This is possible because this particular model is trained on the new dataset the instruction reply dataset, that is, let me go up, this, where it is, yeah, this dataset. Okay, this is the context, and on this context the questions were created like this, and the questions were given to the model, and then the model was instruction tuned, and then we get such an answer. So if you want to try something else, okay, let us say, tell me about adversarial machine learning, and you see that it gives an answer. If you are if you still want to know, try something else. So for an example, if you want to try, let us say, what we can try, we can ask, okay, we can ask, tell me about the large language models. Okay, let us see what it talks about. Okay, this is something that I'm doing right in front of you. Okay, or we can actually do something like this also. So instead of tell me, you can say, what is large language models. Let me change that also. But before that, let me execute this and see what kind of answer I get. And I see there is a challenge here. Let me just, okay, no, it's not the problem. Just give me a moment. Yeah, I think I have not initiated the instructor. Let me run the instructor. Okay, I'm going to run the instructor, and it is going to take a little bit of a time, because when I was doing the presentation, when I was preparing the presentation, the environment had crashed. So I forgot to initiate this. Just give me a couple of minutes. So the training is going on. We have 2 epochs done using the dataset that we are already having. The dataset is pretty minimal, and that's why you see the training is happening really fast. If the dataset is huge, depending on the context, then yeah, the training is going to take a considerable amount of time. Keep those things in mind. The most important point, again and again, I reiterate here, is that the model size is going to be very, very minimal. It's depending on the base model that you choose, and depending on the type of instructions, and depending on the type of the parameters that you are going to use, the models are going to be very, very limited in size, and these models can be used in any of the contexts that you are looking for. This is this is a very different way of looking at the entire process of using the large language model, and anybody can do this. Anybody can work on this instruction tuning. It's all completely almost automated. The large language models, that is open source, helps you to create the instructions and helps you to create the dataset using TxtInstruct, and you're just going to bring these things together from using your context. So your only work is to create the context, and create the context in such a way, experiment with it, practice with it, and come out with a good solution. That is what you're going to do, and I hope that you guys really see the benefit of working with such a model. So let us go down directly here. I suppose, yeah, extractor. I'm going to initiate the extractor right now, because the model is ready, and I'm going to initiate the extractor. And then once the extractor is ready, we see the output, and I'm going to use I'm going to ask this question. So what is a language? What is a language model, and what is the answer? Now here it says that I don't have the data. You may be wondering, Kamal, we expected the data. See, the reason why it does not have the data is this particular data set, this context, which I had already trained it does not have the information regarding large language model. So it cannot actually provide the data, right? And it is actually it is providing the information upfront. That itself is a great news, right? And it is doing in a regular natural language. So these are the benefits that you get out of instruction tuning it. And can you even believe that you can use regular prompts to work with Flan T5 small model? It's not even a big Flan T5 U2. It is a small model, and from that, if you are able to get such a reply, what you can do with really a big model. Think about that. And I want you guys to practice with such bigger models and see how the outputs are, and see what kind of benefits or what kind of improvements you can make in your particular product. With that said, let me go back to the presentation and let me recap. So we saw the steps. So we decided the base model. We started with the T5 Flan small. We worked with the context, that is Wikipedia context. We used the Wikipedia context that is already uploaded by Numal team. Thanks to the Numal team for that. And then we brought in we created the base data set. and the instruction replay pair, and then we tuned the model. We tuned the flan T5 small model, and we saw how the output was much better than the flan T5 small open source model that is already available. This is what I wanted to make it. This is what I wanted to share in this particular presentation. And the smaller the model, the efficient the model is. You can store the model in any of the devices that you are planning to, whether it is a server, whether it is your device that is going to give some predictions. All those things are possible with this. I hope you like this content. Do leave a like, share it with others, because this is a new kind of technology which can help you to to leverage your own context, not like vector stores. This way of working with context, you can leverage it for new tasks. So it could be a new domain that you're working upon. It could be a new the area of interest that you are trying to research. All those things can be put as a created as a context, and then instruction reply pairs can be created with TxtInstruct, and without further ado, you can create the new models. With that said, I would like you guys to subscribe to my channel for further updates related to a lot of information on Python and Python related libraries and the ecosystem. With that said, I would like to leave with 4 words this time, that is practice, 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 practice. With that said, have a great day, guys. See you.